Hey there, HackerFrogs, it's me, the Shy Hat, and we've got a stream today. Well, we have a stream almost every time we stream, we would like to assume, but what we're going to be doing today is we're going to be starting out with some Baba Is You. This has been a great little game that we've been playing that has a lot of programming-like elements and hacker-type problem solving, and we're also going to be doing some hacking against echoCTF. So the echoCTF platform is quickly growing to be a growing to be one of my favorites in as far as cyber security CTF platforms are concerned. And today we're going to be doing some hacking against this network right over here called the HackGDL 2024 event, and it has some beginner level challenges which we're going to be taking a look at, but that's going to be in the second half of the stream. In the first half of the stream, let's do some Baba Is You. So I'm going to boot up my game, and then we're going to I just need to a little bit of time to set this up. I just need to bring the game up over here, and I will bring my Kali machine off the screen, and then we're going to full screen Baba Is You. Okay. All right. And then we're going to connect the sound. So the sound isn't connected by default. I'm sure you're very interested in how I do my stream setup, but let's connect the sound right now. So I'm going to connect this to the Baba Is You game, and you should be able to hear the music from the game. Okay, great. All right, so if you think that the volume is too loud or not loud enough, let me know, and I'll try to address this as you know, on the fly. Anyways, so let's continue playing the game. So once more, we're going to continue where we left off. I did a little bit of research offline about some of the levels we were stuck on. So this is the Tiny Pond level, level 8. And let's take we got stuck on this level, and we got stuck on a couple of levels. This is one of them. So let me think. I think this could be zoomed in more. So what I'm going to do is I'm going to go over to my settings, and I'm going to set the zoom mode to stretch, and let's see if that, yeah. So that's that'll make everything bigger. All right, so I want as much real estate on the screen as possible. That's what I'm looking for. All right, so the last time we were on this level, we got stuck. So first of all, let's review the rules that are happening in this level. So first of all, Baba Is You. We're this white creature over here, and it's open. Open means that that the object, in this case, is going to be consumed and is going to consume objects that are shut. And we see that the water is stop and shut. And in this case, that means that when Baba runs into the water, he's going to open the water, meaning that both the water and Baba is going to be consumed. So if Baba moves into the water, then Baba is destroyed, and we don't want that. But we do need to eliminate one of these water tiles. So this one over here, in order to get access to the wind tile. So I think we need to get rid of, we need to get rid of this tile right here to get access to the wind tile. And so we need to find some way to achieve that goal. So Baba can turn into other objects. So we don't need to necessarily be Baba. And what we need to do to finish this level is we need to use the flag and the key. So what we need to do is we need to either make the key a flag, or we need to make the flag a key. So let me demonstrate over here. So first of all, what we're going to do is we're going to turn the flag into a key. So now we have 2 keys. And now that we have 2 keys, we can become the key. So I'm going to move the flag tile out of the way. Let me get around here. And then we're going to become the key. So we're going to become the key object. And when we become the key object, we now move the key objects around. So why is this important? It's important that because we have to get rid of one of the water tiles. And when we get rid of one of the water tiles, we need to also have a character that we can control. If we were to use Baba to do this, and Baba were to run into one of these water tiles and be destroyed, then there wouldn't be any other player for us to be, and we would lose. But in this case, because we turned the flag into a key, and there are 2 keys, we are both of these keys. So we can use one of the keys to destroy the water, and there'll still be a playable character, meaning that we don't lose in that case. So let's go over here, and let's destroy the water. And after that, we get access to the wind tile. And in this case, we can turn Baba into the win condition. So we're going to go over here and we're going to form the statement Baba is win. So what we need to do is we need to go over here and move the win tile into position so that Baba is win. So now that Baba is win, when we touch Baba as the key, then we finish the level. So that's what we do. Alright, we're done. Okay, so now we have access to a couple more levels. Let's do level number 9. So level number 9 is Research Facility. Okay, and we also got stuck on this level over here. And this level is all about using this lightning bolt to move around. So in order to have this lightning bolt move around, we need to move into position. The lightning bolt also cares about what direction it's pointed in. So because we pushed it over here, it's now pointing in this direction, and it will move around like this. So it'll move to the wall, and then it will move back in the other direction. So what we're going to do is we're going to make Bolt move. So when we make Bolt move, it's going to move like I was talking about. It's gonna move like this, and it's gonna move over here. So first of all, we're going to race the lightning bolt. So what we need to do is we need to move the statement into a position where we can we need to move the statement into a position where when we move it into position, then the lightning bolt is going to have to move. We're going to have time to move over to here. What we're going to do is we're going to move into position, move the defeat tile over to here, and then we're going to set it up so that skull is defeat. What the lightning bolt is going to do is it's going to move over here, and then it's going to move back, and it's going to move the skull tile out of position, and then skull will no longer be defeat in this case. So let me just demonstrate. So let's so we make the lightning bolt move. So it's going to move, and I need to start moving along. So as we come over here, I'm going to get into the space, and when I get into the space, we see that skull is defeat. So currently skull is defeat, and if I were to move through the skulls, then Baba would be destroyed and it would be game over. But the lightning bolt is moving. So when the lightning bolt moves to the skull tile, it's going to displace it, and then skull will no longer be defeat. So over here, the lightning bolt moves, and then it moves skull out of the position so that this statement no longer qualifies. So the lightning bolt is still going to keep on moving, but in the meantime, I'm going to move Baba down here, and I'm going to move the win position out over here. So what I'm going to do is I'm going to wait until the lightning bolt comes back around into this position, and then I'm going to move the win tile into position where bolt is win. So now the lightning bolt becomes the win condition. So let's move into the lightning bolt and finish the level. Okay. Alright, so let's move over to the next level, which is level number 11. So this is something that I had to look up because I was stuck on this level for quite a while as well. But when you see the layout of the level, you'll figure out what exactly is going on. So we see here that let's review the rules for this level really quickly. So Baba is you, which means we move Baba around. We also have Kiki on the board. So Kiki, we can very easily set it up so that Kiki is push, which means that we can move Kiki around. The problem with this level is that wall is stop, which means that we cannot move past the walls, and we need to move past the walls in order to get access to the win tile over here. So what we need to do is we need to set it up so that Kiki is push. So when we make Kiki push, that means that we can push Kiki around. And this is where I read about a new technique, which is basically using object stacking. So you can stack objects on top of text. So this is text right over here. So if we were to move Kiki into the corner over here, and then we were to move this entire row of text down, okay, we can't do that because Kiki is push. Because Kiki is push, Kiki is a solid object. So what we need to do next is we need to move Kiki as push. We need to break this. So now that Kiki is not push, we can move the text on top of the Kiki object. So we move wall is stop down, and then stop, this text tile over here, is on top of Kiki. So wall is stop is on top of Kiki. If we were to become Kiki, then we could then use the Kiki object to break this statement over here. So what we do is we go over here and we change it from Baba is you to Kiki is you. And now we're controlling Kiki, and Kiki is inside of this text statement. So wall is stop, but we are inside of stop, which means when we move up, we break the statement wall is stop. So now that the statement is broken, we can now move through the walls. And if we can move through the walls, we have access to the win tile. So now that we have the win tile, we can very easily make the statement wall is win. And if wall is win, that means if we touch any of these walls, then we finish the level. So let's touch the wall and finish the level. Okay. Alright, so let's move on to level number 10. So level 10, this one's called wireless connection. I have not seen this one before. I hope it's not too difficult. I hope I don't get stuck. Let's see. Alright, so this is, let's review the rules. So pipe is stop. Pipe is stop, we cannot move through the pipes. Baba is you, we move Baba around. Flag is flag, meaning that the flag cannot transform. So otherwise we would be able to turn the flag into some other object. Bog is defeat. But what counts as bog? Is bog this kind of green water, or is bog this land right over here? So if I move, okay, so what is bog? Is this bog? No, this is not bog. So bog is probably this water. So I touched the water, and I guess that was bog. Okay. So what other objects are on the field? So cog is stop, which means we can't move through the cogs, and robot is push. Robot is push, meaning that we can push the robot around. we have access to move, and we have access to the and tile over here. So what we want to do is we want to move an object across the bog, and we want to use it to access the win tile. So how do we do that? So cog is stop. Do we want cog to be stop? So let's see. Okay, so let's I'm thinking that the objective for the level is to create flag is win and win that way. So first of all, what we need to do is we need to access this side of the map over here. And I think what we need to do is we need to make one of these objects move around. So let's just assume that we're going to be using the robot for this case. And let's just move the robot around. So maybe we're going to move it over here, and because it's facing this way and we pushed it this way previously, then it's going to be moving in that direction. So let's make robot is move. So robot is push, it is no longer push, we'll make robot move. But also bog is defeat. Bog is defeat, which means that when the robot moves, I think the robot can move across the bog, but whatever object that we're controlling cannot move across the bog. So if we make robot is move, then the robot is going to move, and we see that it can successfully travel across the bog without being destroyed. So we can have the robot walking around. Maybe what we can do is we can make the cog both push and stop. So if we make the cog push and stop, that means we can move the cog around. And that means that, oh, so that was not what I wanted. Okay, so we're not going to make the cog push, because if we make the cog push, that means that the robot can move the cog. We don't want that. Okay, so we cannot. So in this case, U is stuck over by the pipes. So the pipes restrict our access to the U tile, the U text, which means that we cannot assume the role of any other object in this level. So what we need to do is we need to somehow find a way to move these objects. So what we want to do is we want to move flag and rock and win. We want to move them all over to this side of the screen so that we can use them in our equations. So bog is defeat is another thing that we cannot modify in this level, which means that our character can never touch the bog over here. So the question is, how do we get the robot to change directions? So it would be nice if we could get the robot to change directions. The flag cannot be interacted with. So if we make it so cog and So if we make it so that we control that both the cog and the robot are moving. So let's break this statement here. Robot is move. So cog is stop and robot. How about robot and cog? So let's set this up. So robot and cog and robot. Cog and robot is move. So if cog and robot is move, then they're both moving around. I don't know how this necessarily helps us. How about we set it up so that, oh, okay, so this, I didn't want to do that. Okay, so we need to make sure that that the text is not moved around by... Okay, so do we want to make things move, or do we want to make things... Do we want to make things push, or do we want to make things stop? If another way we could go about this is we could try moving the text across the bog. And if we're able to move the text across the bog, does that help us out at all? So, for example, we could move the text all across the bog. Could we set it up so that we create a new statement? So, for example, flag is rock. Flag is rock and win. Oh, you know what? That could be the case. Okay, I'm going to reset this. So maybe we want the maybe we want to set this up so that the cog and the robot are moving around, and we want to make it so that flag and rock are win. Flag and rock are win. So we could set this up so that the and is being pushed around. So first of all, we need to set up something that is pushing the and over here. Okay. So for example, if we have the robot over here, and let's set this up like this. Okay. So if we have the robot is going to move this way and then move this way and then move, it's going to push the and text into the position. So we want the and text to be here, and we want some is text over here. So, whoops. Actually, you know what? That it doesn't really make too much of a difference. So we want to move this and over here to flag and rock, and then is win. So if we were able to trigger this, then when the statement is in place, then we can touch the flag and we can win. Robot is push. Okay, let's set it up so that cog is push, because we need both of those objects. And I'm going to set it up so that cog is push now. So I'm going to set the cog up over here. Okay. So what we're going to do is we're going to start making these things move. So I'm going to break push. So cog is move. So cog is move is going to move around, and it's going to move the is text into the position. So I'm going to break the statement, and then now the cog is stopped, and we've got rock is win. So we're going to then set it up so that robot is move. So the robot's going to move, and then it's going to move this and into position. So it moves the and into position. So flag and rock is win, which means that because I'm beside the flag, I can move into the flag. Nope. Okay. Okay, so I'm going to move into the flag, and at the same time, the statement for the win was completed. Okay. All right, so I think I've completed this. So this, have I completed this one, number 00? Let me take a look and see if I've actually completed this. I must have. Okay, I think we have these extra levels to complete. And I don't know if... I think I've completed this one and this one. So I need to complete 3, 4, 5, and 6. So let's do 3. So 3 is this level called Tiny Isle. Let's see what it's all about. Okay, so what are the rules? The rules are, this looks very similar to another level that we did. So water is stop and shut. Water is stop and shut. So we can't move through the water, and the water will be destroyed by the open object. So Baba is you and open, which means that if we move into the water as Baba, then it's game over. So we don't want that. In the last level, we made it so that key, we made some duplicates. So we made flag. Flag is key. And in this case, the flag turned into a key, and now we can assume the identity of the key. So it would be, we would make key is you. So now that key is you, we need to find some way to break out this win tile, this win text, because, but there's no one tile we can destroy to get access to the win tile over here. So if we would go over here and we destroy one, we still don't have access to the win tile. Okay, so what can we do here? So, oh, I think I know what's going on. Okay, so let me go back. Okay, so what we can do here is we can get access to these tiles over here. So if we're able to destroy one of these water tiles, then we can get access to this text right here. So water is stop and shut. We can make it so that we can make something water. So maybe water is you? Could we make water is you? Let's do a little bit of experimentation. Okay, so let's move this all down. So Baba and water is stop and shut. Could we do that? So what could we do to this statement to okay, let's so we can't break. So the open, let's stop and shut. There's Baba over here, we can't push him. So maybe something and water is stop and shut. Something and water is stop and shut. Okay, let's rewind. Let's rewind to when we destroyed the water tile. Right about here? Okay. So what can we do? So we can't push Baba or the key. So let's see if we can do a little bit of something and water is stop and shut. So can we make it so that Baba and water is stop and shut? That doesn't really help. Okay, what do we have here? So key is you, is stop and shut, is stop and shut. Is there some way we can manipulate this another way? Key is you, Baba is you. Does this change anything? Water is stop and shut. There's the win tile up here. Can we... We cannot put the... Okay, let me reset this level. So we reset the level. And is there a statement we can make so that we can get the win tile out? So we want this win tile, we want access to this win tile. We have water is stop and shut. We can get access to this. The problem is that we can... Oh, you know what? Let me... Okay, so Baba is you and open. That's great. Okay, so what we're going to do is we're going to move the text up here so we can start messing around with it. And we're going to make it so that we've got keys. So let's make the flag a key. So the flag becomes a key. And then let's make... Maybe we can make Baba a key as well. Okay, okay, let's... No. So... We've got our Baba over here. Let's go back. So flag is key, now we have 2 keys. If we could get 3 keys, then we could finish the level. So flag is key. Let's do... Oh, nope. So let's make it so that P and Baba is you, which means that we're moving all 3 of these. Okay, so now that we're moving all 3 of these guys, let's see if we can make... Let's see if we can somehow... Key and Baba is you. We need to make something open now. Let's think about the water is stop and shut. Water is stop and shut, but if we were to make something and water is stop and shut, would we be able to win? So if we make Baba stop and shut. If we're to make the key stop and shut, key and water is stop and shut, means that they would both stop objects and they would both be shut. Key and Baba is stop and shut. Is there any other thing that we could manipulate over here? So the problem with we can't move and shut, open. We have to make something else open. We have to make something else we can't move the water. This water text we can't move out of the way. The stop text and the shut text. If we do both open and shut, does that cancel out? But we need it to be shut because we need to destroy these water tiles. Water is, if we could set it up so that, okay, let's reset the level. Okay. So we could modify these rules over here. So water is stop and shut. We could the problem is we can't move this is text. We can't move the is text out of position here. We can only move it up and down because the moment this is broken, the moment this statement is broken, then we lose the game. So let's make Baba is something else. So if we could make it so that Baba is you and key. Baba is you and key. Okay, that means I become a key and then I lose the game. Okay. So let's see. So if we were to set it up so that key is flag, let's set it up so that key is flag. Okay, so we're gonna move this into position here. Key is flag so that we have many flags. Okay. And then we set it up so that flag is you. Nope. Flag is you. So now that flag is you, we can make flag is you and Baba. Flag is you and Baba isn't going to work because if we make the moment we all become Baba, we are no longer the flag, which means that we lose. Flag is you and okay, so what can we do? If we could turn you know what, I'm going to I'm going to revisit this level later. Let's just go back to the map. And then let's go over to the next level. So the next level is number 4. hopefully it's not similar to the last level. Dim signal. Let's take a look at this level. Okay, so this is a more advanced version of one of the other levels we completed. So we've got flag. So flag, and so can we set it up so that the robot and the cog are moving things around? So we want to make it so that is win over here. So for example, we've got is and over here, and we want and over here, and we want and over here. So we want to make this statement flag and rock and ice is win. Flag and rock and ice is win. Of course, the only object that we have access to is the flag, which means that when the flag becomes win, then we're going to be able to win. The problem is that we've got 3 pieces of text to move, but we only have 2 objects that can move. We've got a cog and we've got a robot, and we ourselves cannot cross this green river over here. If we try to do that, then we lose, so we can't do that. But we also need these 3 text pieces to be in position in order to activate the win condition. So what do we do in this case? So something has to be... Okay, I think we can reuse one of these. So I'm going to... Okay, I don't, wait, can we reuse one of these? Okay, what we can do, okay, let me reset the level. So reset the level, and what we can do is after we've put everything into position, for example, got robot is push, we need to push the robot into position over here. So if we push the robot into position, and then we push the cog into position. So let's move the cog. So that's the position for the cog. Okay, so the robot and the cog are in position. We need to set up our text. So the text is going to be, hold on. So there are 2 spaces right here. So we need to make sure that one of these 2 spaces is occupied. What I'm going to do is I'm going to set it up so that the robot moves this is over here. So we've got the robot. We can't move the robot. Okay, fine. We'll move the cog. So the cog over here, we're going to make sure that it can move, and we're going to move it by setting it up like this. So cog is move, so that means cog is going to move over here, and I'm going to... Oh, nope. Hold on. Okay, so the is in the cog is in position now. All right. So now I don't need the cog, this cog text anymore. So what I'm going to do is I'm going to move the cog text over here, and then I'm going to move the word stop over here because we don't need that. I'm going to move the and text over here, and then I'm going to push the robot, and I'm going to do robot is push. Okay, so robot is push, so I can push the robot into position. And then I'm going to make the robot move. So the robot is going to move. Okay, so the and is in position now. And then the robot is going to move back to the other side, and then I'm going to break the statement, and then I'm going to move the last and into position. So this and is in position now. I'm going to set it up so that robot is push, and then I can move this robot into position here, and then we're going to make the robot move, and we're going to sit on top of the flag. So when the robot moves this final and text into position here, then the statement will be flag and rock and ice is win, and that means we win. So the robot moves, and then we win. Awesome. Okay. All right, that level is done. Let's move on to the next level, which is level number 5 over here, which is called Dungeon. So let's move in. Okay, so this is very similar to the other level where we had to move Kiki into position and then break this statement over here against the wall. So what are the rules? Baba is you, we're moving Baba around, wall is stop. What we want to do is we want to break up the wall is stop statement so that we can move through the wall and get access to the win tile. When we have access to the win win text over here, we can win. All right, so but the problem is Kiki is you, So there's no push. We can't push Kiki into position. So what can we do here? So maybe Baba is you and Kiki is you. So if Baba is you and Kiki is you, then we can move both of them. Oh! That's strange. It's strange how we're able to stack. So okay, so if you have a playable character, so if we're both Kiki and Baba, then we can stack the text objects on top of other objects that we are playing. So in this case, we're able to stack stop this text on top of Kiki. And because this is the case, we can break wall is stop by going up like this. Alright, well, we learned something. Okay, so now we can just set it up so that wall is win again. So down here, wall is win, and we win. Okay. Alright, so we might have time for 1 or 2 more levels, depending on how much trouble we have. Let's move on to this level number 6. So it's called Evaporating River. Let's take a look at what this is all about. Okay, this is a pretty claustrophobic level. So what do we have here? So Baba is you. We are Baba. Water is sink, which means that anything that moves into the water tile is going to sink and be destroyed. Cog is push and melt, which means that the cog will melt. What does the cog melt? Water? Well, no, it wouldn't be water. Cog is push and melt. Maybe we'll see what the consequences of that are a little bit later. Skull is defeat, so we can't touch the skulls. If we touch the skulls, we're defeated. Water is hot. So cog is push and melt. Okay, so melt objects will be destroyed by hot objects. So water is sink, which means that the water will destroy things. Wall is stop. Wall is stop. And we have to find some way to move this flag text into position here so that flag is win, and then when we touch the flag we can win. Alright, so what is the so if we break the statement water is sink, then we can move through the water. Okay? So if we can move through the water, we can't break this statement here, water is hot. And let's see, cog is push and melt. Cog is push and melt. So the cog, if we try to move it across the water, it's going to be destroyed because cog is melt. And water is hot. So if we move the cog over here, it's destroyed. So something tells me that we want to move the cog across. So the flag, we cannot move the flag either. So we've got this cog over here. Water is sink. Water is what else can we make water? So we can make water is stop. That doesn't help. We can make Baba is you. Flag is water. Flag is water? Do we want... Oh, flag is water might be useful. So if we make flag is water... No? that doesn't help very much. Flag is water doesn't help. If we could make water is flag, that would help. But that doesn't seem to be something we can set up. Skull is defeat. So we cannot become the cog. We cannot become anything else. So Baba is you, the you text. Oh wait. You is. That doesn't really... Baba is you, water is sink, win is... wall is stop. Water is sink, stop. Skull is defeat. Skull is defeat. Cog is water. Cog is water. Cog is water. We could do cog is water. Let's try that. So cog. Oh, but if we make cog into water, then that doesn't help us, because if we could make something else cog, then that would help. But if we make cog into water, that doesn't help us. So we can't... Water is... Water is wall? Water is wall. Okay, let's see if we can set it up so that water is wall. Water becomes the wall. Okay. Okay, so let's move this over here. Whoops. Okay. So water is wall. The wall is stop. So that doesn't... Okay. So that was a bad idea. So water is wall. What else could we turn the water into? The other issue is water is hot. So water is hot. Water is sink. Does making anything else sink help us in any way? So wall is sink. That doesn't help us either. Cog is push and melt. Melt. Skull is defeat. Cog is hot. Wait, if cog is hot, does that... No? No, water is hot. Water is hot. Water is hot. We can move the cog. Why do we even want to move the cog? Okay, we want to move the cog so that... We want to move the cog so that we can break something up. Okay, so we can push the cog, and do we want to push the cog? Cog is sink, cog is water, cog is we cannot touch the skulls. We want to flag is win. We cannot touch the skulls. Is this what we're supposed to do? We're supposed to move all the text over? If we could move all the text over, then we could make flag win. But we can't do that. Okay. If we could move the cog across, then we would be able to win. So what can we do to set that up? Alright. So something is sink. If we could also destroy one of these skulls, then we would be able to more easily win. We have access to 1, 2, 3 tiles that we can use to push, but we need 4. If we could move the cog, then that would help a lot. But cog is push and melt. Cog is push and melt. Cog, can we make something else? Cog is sink? No. Wall is stop. Water is hot. Skull is death. Skull is defeat, rather. Is skull. So we could turn the water into skulls. That doesn't, if we turn the water into skulls, that doesn't help us either. Because our guy can't cross. Well, you know what? Let's just set it up so that water is skull. So water becomes these skulls. We cannot touch the skulls, but yeah, that doesn't help us very much at all. Okay, so can't move this over. We can't push this over. We cannot break water is hot. Let's reset. Okay, so currently water is sink, which means that water is sink. So break water is sink, and then we can okay, so that doesn't necessarily help us, but we have access to the cog, which we can move around. But because we had to get rid of some of our tiles to do that, it doesn't help us very much. Okay, let's reset again. So water is sink, we break that up. Then skull is defeat. The cog. Water is sink. Wall is sink. Wall is sink? That doesn't... Wall is sink. Wait! If we make wall is sink... No. We can't make wall is sink. Flag is sink. That doesn't help us. That doesn't help us either. U is water. Okay, no, that doesn't help us out. Skull is defeat. We could make other things defeat. We could make other things skulls. We could make other things water. We could make other things hot. Or we can't make other things hot. We can make the water. Water is skull, or water is defeat, or water is wall. Okay. Water, sink, cog. Water is hot. All right. So I guess we're stuck. And what we're going to do is we're going to move on to our next stream topic, which is going to be the echoCTF. So let's get out of here. But thank you very much for watching our Baba is You segment. We're going to stop playing for today, and then we're going to play our music. Make it a little louder. And then let's do some hacking. So we've got our Kali Linux machine ready to go over here. Let's make this full screen. All right. So what are we doing? So we are going to be hacking against the echoCTF.red network, and that means we're going to have to connect to the network. So we've got our OpenVPN. Let's make a couple of new tabs so that we can switch between them when we're working. And new tab number 3. Okay. All right, so let me make sure that, okay. So my volume should be coming in nice and clear. Okay, so in our first tab over here, we're going to do OpenVPN, and we're going to connect to the echoCTF network using the VPN key. It's going to ask for the password. Okay, so in the other tab, we're going to move over to our temporary directory. So because we don't want to have a bunch of stuff cluttering up our file system. And then that's not what we wanted. So this is echoCTF.red, and we're going to be hacking against this network right here, which is called the HackGDL event from 2024. I'm assuming that it happened quite recently, but they've got a couple of they've got some easy level machines that we can work through. So we can go over to the network, and we see that all of the machines are powered off, so we're going to have to power them on. Let's move over to this first challenge over here, which is called Pingy. So we're going to click on that one. So we've got some tags. So command injection, basic, non-rootable, timed. So let's power up the machine. We're going to power up the target, and that's going to give us access to the IP address. So let's wait a couple of seconds while this comes up. What I'm going to do is I'm going to create a little notepad file that I'm going to be keeping track of notes. So let me go over to I've got my write-ups, I've got my echoCTF.red, and let's make one for, this is called the HackGDL 2024 event. And this is called Pingy. I'm going to create a little Pingy. And then I'm going to make a little notes file. So I've got my notes file. I'm going to bring it up on screen. Let's make this notes for Pingy. And let's make this nice and big so when we refer to it, we can very easily see what's going on. So the first note I'm going to make is looks like an OS command injection challenge. All right, so I'm going to bring this off the screen. All right, so let's take a look at what's going on here. A brainless pingy, or else pingy without a brain. So this gives me the impression that we're going to be working with a ping command that's happening inside the app. So first of all, let's refresh the page. So the address for the machine is at this right here. So what we're going to do is I'm going to click to copy it to the clipboard. Great. And so do we know which port we're supposed to contact? I'm going to try. This is the Timberdoodle. It's a cute bird. Anyways, so let's try accessing this service on HTTP. Okay, so this is what's going on. So PHP is set get ping. Let's see, system ping count 1. All right. Else highlight file. So it shows us this file right here. So I guess the game is on. So I'm going to write in my notes. Access the app through the web browser. Well, I guess we could access it by other means as well. So we've got the web browser. I guess it would be port 80. What we can do is we can send a quick nmap against top ports. Top ports equals 100, and then the IP address. So the IP address is this right here. Copy that. No targets were specified. Were they not specified? I guess this might be the wrong. This might be the wrong syntax. So let's just run nmap by itself, and with very verbose output. No targets. Oh no, wait. We have to make sure that the HTTP is in here. And I guess we could do top ports equals 100. Okay, so we just have port 80. Well, this among the top 100 ports, we only have port 80. So let's try sending some get ping. So I think what we need to do is we need to send this. Let's do a little bit of analysis through ChatGPT. So we got ChatGPT here, and let's ask, what is this PHP code doing? Okay. This PHP code handles a request and performs one of two actions based on whether a specific get parameter ping is set. Here's a breakdown. Check for the ping get parameter is set get ping. If the ping get parameter exists in the URL, the code will proceed to execute the commands inside this block. For example, if the URL contains ping1, this will be true. Okay, so ping is the name of the URL parameter. All right, let's try that. So we're going to give a parameter. It's going to be ping equals 1. See if that does anything. Okay, so this output looks like Linux or Unix ping output, which means that we. Okay. Let me add this to the notes. So over here, access the app through a web browser, sure. And then the next note is going to be the the app is accessed through the ping URL parameter. For example, that is ping equals 1, I guess. Okay, so the output looks like Unix or Linux. I guess I should capitalize this as well. Unix or Linux ping command output. So what can we do? We can try any number of different OS command injection payloads. So let's try ping equals 1, or what happens when we do ping equals 0? So ping equals 0, ping could equal anything, I guess. So ping equals 0. Let's try a semicolon and then ID. That doesn't necessarily do anything. Let's try asking ChatGPT if it has any brilliant suggestions. So we've got our execute a ping command. It does system ping URL encode. Great. The code sends a header to the client indicating the content type of the response will be plain text. Okay. Let's see. This line uses system function to execute a command on the server. The command executed is ping C1, which sends one ICMP echo request to the target. Okay. All right. If the ping get parameter is not set, the code will display the source code of the current file using the highlight file function, which syntax highlights the PHP code for readability. All right. So if ping is present in the URL, the script performs a ping to the server's own host and displays the result. If ping is absent, okay. Potential vulnerability. This code could be vulnerable to command injection if not properly sanitized. Although the ping target is the server's own host name, if an attacker manages to manipulate the server HTTP host by setting a custom host header, they could inject malicious codes into the system call. For example, if an attacker sets the host as this over here, the executed command would become ping1 example.com and then rmrf, which would lead to things being deleted on the web server. Okay, so let's add that to the notes. So it seems that the target of the ping command is the web server host, which can be modified in the HTTP request through request headers. Through request headers. Okay. So what do we have here? We could set something like this, and then host example.com. Well, or host localhost. What is it inside the code? Let's take a look at the code real again. So it's HTTP host. HTTP host. So that's the value contains the host name of the server, the domain or IP address in the URL. Okay. All right. So before we bring up our notes again, so we can set it up so it's host equals localhost. We could do localhost and then do the semicolon to end the command, and then we do who am I, and then we could get or cat. We do cat Etsy password. Okay. and that would output the usernames on the system if successful. Okay, so let's try something like this. So we could probably do this through curl, and we would go over here. So this is this IP address right here. Let's copy that. And then let's clear so we're back at the top. So we're going to curl, and we're going to do a get request to this right here. So it's HTTP. And then we need to set the, well, we need to make sure that there are 2 slashes. And we need to make sure that there's that we're sending it to the correct, we're using the correct URL parameter. The URL parameter is ping equals 1, ping equals something, and let's set it like that. Okay, so let's do a custom host header, and in this case, the custom host header is host and then localhost, and then we supply the semicolon and do the command injection. If the command injection is present, we would do cat etc password, and let's see if this payload works. Okay, so let's make the curl very verbose because I like to get more output from this. Okay, it says bad connection or bad request. So host cat etc password, this doesn't work. Let's see if we don't include. Okay, so cat etc password. Let's try commenting out the rest of the command by using this character right here. Okay, and let's see if this gets us something. Okay, this still gets us a bad request. Let's try omitting our payload and just submitting a custom host. Okay, so with the custom host, this works. At what point does it break? So if we supply the semicolon, does it break? Okay, so sending the semicolon doesn't break it. If we send another command along with the host, does it? Okay, so this works. So we've achieved OS command injection. We were able to submit a custom host and then end the command and then send a second command, which is ID. So let's send the ls command. So we've got just index.php in here, and we don't know where the flag is. We're probably supposed to get a flag. Let's see if the challenge description tells us what kind of flag we need to get, or where we're going to get the flag, rather. Okay, here. Pre-exploitation details, target created for this computation, okay? A brainless pingy or else a pingy without brain. We need to, I guess we're looking for a file called flag.txt. So let's try searching for that with the injection string. So we could try find slash name flag.txt. This is probably not going to go through. So it results in a bad request over here. I think it's because we're using spaces. So maybe if we use the plus symbol over here. Okay, so it's still a bad request if we replace the spaces with pluses. So are we going to be able to do? Can we do URL encoding for the spaces? So let's just grab we'll grab the string that we wanted, which is this right here. Okay, and we'll see if we can URL encode this. So we're going to grab this, and then we're going to use some web app to do URL encoding. URL encoding. Thank you very much for following MonkeyShaw14. MonkeyShaw14, let's give you a fun video redeem. We haven't done Hack the Planet, and this is from the movie Hackers, the very iconic meme. Hack the planet! Hack the planet! All right, welcome to the stream, MonkeyShaw14, and welcome to the HackerFrogs. All right, so we're going to do some URL encoding over here. Oh, okay, this doesn't look like a... So this is an app we can use to do URL encoding. We want to encode this command right here and encode that. And let's see if we include this as the name of our command in our curl, if that's going to let us do command injection. Okay, so let's do that. Request completely sent off. All right, so it went off, but we don't necessarily see results aside from the ping over here. So what we need to do is we're going to see what exactly is breaking the command. So let's do ls-la and see if that works. Okay, so ls-la works. It's not the space that is breaking up this. It's not the space that is breaking this this command. Let's do ls dot dot. So ls dot dot is going to do list on the parent directory. So the dot dot seems to be not, it doesn't like this. So do we have to URL encode dot dot? So if we encode this, it doesn't, I don't think it's going to necessarily encode it into anything special. It timed out. Why did it time out? Okay, let's reload the page. URLencoder.com. Yeah, so dot dot just becomes dot dot. It might be a forbidden character, and that's why the maybe the dot is the forbidden character in this case. So if we do ls dot, so ls dot works, but ls dot dot does not work. So if we ask what the current directory is, so let's send the command pwd. Whoops. pwd. So this is var www.html. All right. Let's try to do ls var www. Okay, so this doesn't work. It might not like the slashes. So what does slash URL encode to? So it encodes to %2f. Okay. So let's try turning this into %2f and this into %2f and see if that. So it went through, but it didn't send us. It didn't send us the information that we wanted. Okay, so what do we know? We know that it doesn't like slashes. We can't send slashes as part of our payload. We know that we can't send the double we can't send the double period to try to access the parent directory. So that's out of the that's a no-go. What else do we know? We could do let's see if we have a locate on the system. So we didn't get any results for locate, which means that it's probably not on the system, so we can't use the locate command. So let's try find. Find. Find found index.php. You know what we could do is we could try something we did for a previous challenge. So in the previous challenge, we did what was it? Echo. So echo star. So if we echo star, then we get the contents of the current directory. If we echo star slash, then it shuts down the connection. If we echo star slash star, then it also shows a bad request. So what we could do is we could do let's ask ChatGPT. Where are we? Okay. It seems we can perform OS command injection through the host header. This is a CTF challenge. The app doesn't seem to let us use the slash character. How can we work around this? Okay, since the slash character is restricted, there are several ways to work around it when performing command injection, depending on the available system utilities and shell being used. Here are a few strategies. Use URL encoding. Even though slash is blocked, sometimes URL encoding might bypass the filter. You can try encoding slash as %2f. Use an alternate directory traversal method. Instead of slash, you could try using symbolic links or environment variables that point to directories. Environment variables. Home can be used to reference the home directory. Okay, let's try that. So let's go back and let's do ls with the home variable and see if it gets us anything. It doesn't work. So what else could we do? So home can be used to reference the home directory and tempdir for the temporary directory, depending on the environment. Okay, so first of all, let's find out what user that we're working as, and we can do that with the whoami command. So we're www.data, and www.data doesn't necessarily have a home directory, but I guess we could try to see what's in www.data's home directory. So if we do ls tilde, then we don't get any good output from this. It doesn't. Oh, okay. So it looks like there's a directory called HTML in here. All right. So what else can we do? Okay. So you can use dot for the current directory and dot dot for the parent directory. So we found that we could use the dot. So we can do ls dot, and that works. And we can do, but we can't do ls dot dot for the parent directory. That results in a bad request. So what we can do, hexadecimal or octal encoding. Let's see if this works. You can try encoding slash as this, backslash x2f, backslash x2f. Okay? Backslash x2f. So did this work? Okay, so it looks like we did the ping. Backslash x2f. We weren't able to get okay, so the slash didn't work. This this encoding doesn't seem to have worked either. Let's take a look. So there's octal over here as well. Use a wildcard. In some cases, you can use a wildcard to represent parts of the path. This assumes that the path you're containing contains predictable patterns with a wildcard that can match. Use built-in system commands. Some commands can be used to traverse directories that create the effective slash without needing the actual slash character. For example, something, something, something. By testing these methods, you may find a way to around the restriction. Find dot name. Okay, so let's try to finding using find within our current directory. So that means we would do find dot name. What is the name? The name will be index.php. So we were able to find index.php. That's kind of good news. Okay, so we're trying to use command injection to locate a file called flag.txt. Please use that in your examples instead of the rm command. And we also want to ask if we are not able to use the slash character, can we use the find command to locate flag.txt? Oh, you know what? You know what I didn't try? I didn't try doing duplicate characters. So for example, we could try doing doubling up of characters, locate maybe ls and then ... and see if it filters this. Okay, that shut down the connection. How about ... How about 4 dots? Yeah, still doesn't like it. So if we do 1 dot, that still works. All right. So let's go back. So if you cannot use slash, you can attempt to search for flag.txt within the current directory or parent directories using relative paths. Find dot name flag.txt. This will search in the current directory and in subdirectories. You can also try going up or one or more directory levels. Well, this includes the slash, so that's not going to work. This includes the slash and the dots, which both don't work. But let's try the suggestion. Find slash, and then we're looking for the name, and it's equal to flag.txt. So this doesn't work. Let's take a look. Use wildcard star to substitute directory paths. So find star slash star slash. This will search through all directories and subdirectories in the current path. Use the home environment variable. Use hexadecimal encoding. Use built-in commands like echo or pwd to reveal paths. If you're not sure where to start looking, you can use commands like pwd to find out our current directory. Once you know your location, you can use relative paths from there. Okay, so let's go back here and let's see if there are any hidden directories or files inside of this directory. So we just have our current directory, our parent directory, and index.php. I guess we could also cat out index.php to see if there's anything that we didn't see in there. So let's do that. Just so you know what? The flag could be in index.php. So over here, it doesn't look like this has index.php. Well, it doesn't look like it has a flag in here. This is just the code that we got from that we got previously. Okay, so let's go back. So as mentioned earlier, you could try encoding slash as this or that. Okay, so let's try this. Let's try copying this and supplying this as the payload. Okay, and so this seems to have gone through, except that we didn't get any output from the other command, which means that there's probably some sort of error that happened in that command. But it didn't trigger the bad request. So what else could we try here? Let's take a look at the challenge description one more time. To anybody who's here, what we're doing is we're working on the echoCTF.red platform, and we're working on this target right over here, which is called Pingy. And this is a OS command injection challenge, and we're trying to figure out how to do arbitrary command injection. We seem to be able to do some commands, but there are other commands that we cannot perform. Specifically, commands that that include the ... characters or the / characters. Let's try getting the environment variables. So one more time, how do we get environment variables in Linux? How do we echo? How do we echo environment variables in Linux? What was that command again? Echo home, echo path, print env, right, okay. So let's try print env. Print env. Okay, so we've got our user, www.data, our home, and we've got our present working directory. So let's try ls, la, and then tilde, which will tell us the parent directory. So if our present directory is HTML, our home directory is var www. Let's see if there's anything inside of that directory. So there's only the HTML directory in here. So what are some other environment variables? So my current directory is home. So we've got our shell. Oh, you know what? Maybe we can find out what kind of shell we're running. So let's find out what our shell is. Echo shell. So that resulted in a bad request. I think it doesn't like this $sign character. Maybe if we encase this in some quotes. Nope, still doesn't like it. Okay. Oh no, wait. User bin ZSH. Oh no, it interpreted it as this shell over here. Yeah, that's why. Okay. Okay, that's how about we do a backslash on here so that it doesn't interpret this literally. Okay, echo shell. So no shell was echoed back at us. So I think we can do the same thing with home. So we got a result. So echo home worked. Um, if we do ls slash, this results in a bad request. So can the host, the question is, can the host's HTTP header contain a slash? So we are performing OS command injection through the host HTTP header. Can the value of the host HTTP header contain characters like slash? Okay, the host header should only contain the host name and an optional port number. It does not support path components like slash, query strings, or any other special characters that would typically appear in a URL. Characters like this would not be valid in the host header. Okay. What you can inject? Well, slash is not allowed. You can inject valid characters such as alphanumeric characters, dashes, and dots in the host name. This can be used for command injection if the application improperly handles the host header without sanitizing its value. For command injection, the host header will only allow you to inject commands, but you have to avoid using slash directly in the host names. In such cases, alternative techniques like environment variables, wildcard characters, relative paths, or encoding would be needed to achieve the desired effect. Could we have the encode our desired command in base 64 and decode it on the web server and have the command run? Yes, encoding a command in base64 and decoding it on the web server is a clever way to bypass restrictions. This technique can be useful in scenarios like OS command injection. Encode the command in base64. You can encode the desired command, such as locating flag.txt with find. Okay. You would encode it like this, and then it might give something like this. All right, so let's try this on our terminal. And let's make the command a little more complicated. So we're going to find in the entire file system for a file called flag.txt, and all of the errors would be sent to dev null, which would eliminate them. Okay, and then we base64 encode this. All right. So what else is here? So inject the base64 command, inject the encoded command through the vulnerable input, such as the host header using the echo command to pipe it into base64 decoder on the server. We don't even know if the pipe command works. So if the pipe command doesn't work, then this payload is not going to work. So on the server, the base64 encoded string will be decoded and executed as this. Okay, well let's try what they suggest over here. Well, this is not what we want to do. What we want to do is this. And what we're going to do is paste in the command, but in this case, we're going to echo not this, but this other one, which is this. And let's see if we're able to run this command. So the ping command went through, but the echo command did not. And it might be because, well, you know what? So in the echo command, let's put this between quotes, just in case it's this plus character that is getting in the way. Doesn't seem to be the case. It could be, I'm not sure. Not sure what, so if certain characters are filtered like /u and can encode the command to bypass these restrictions. Base64 command availability. Shell limitations. Depending on the shell and the way commands are executed, some characters, like the pipe, might be filtered. Let's do a little bit of testing. In this case, we need to figure out which base64. Let's figure out if base64 is installed on the target. So base64 does seem to be on the target. It seems like my music has stopped playing, so I'm gonna restart my music. Let's do some jazz. Oh, this sounds like fun. Okay. Okay, so base64 exists. It could be that pipe does not work. So if we send something like cat index.php and then pipe that into base64, then we should get some base64 output if the pipe is a legal character. So the pipe is a legal character. The pipe is a legal character, so we can pipe commands. So okay, so this opens up some more possibilities. So we can use the pipe character, and we can pipe commands through the through the host header, OS command injection. How can we pipe commands to overcome the slash character restriction? Okay, so let's take a look at, so we can use the pipe character in the OS command injection, but are restricted from using the slash character. You can still pipe commands to overcome this limitation by using alternatives like relative paths, environment variables, wildcards, or built-in shell commands to achieve your goal. Here are several strategies to bypass the slash character restriction while using the pipe character in command injection. Use relative paths. So since you're restricted from using slash, you can use current directory and parent directory in the case of slash. Okay, so pipe the result to Zarg's cat to print its contents. But this only works for the current directory. This will search in the current directory. Okay. You can also move up a directory by using // So use wildcards. You can use the wildcard star to represent parts of the directory structure, effectively bypassing the need for a slash. This will search in all subdirectories from the current location. Alternatively, you can use this searches 2 directory levels deep using wildcards to traverse directories. Use environment variables. Use hexadecimal or octal encoding. Combine with base64 encoding. Using PWD and LS. Okay. Here are some examples of commands you can use using pipes to help them locate. Find. Okay, so here's another question. What are some alternative methods of referencing the top level directory without using the slash character? Use environment variables. Yeah, you're giving me some slashes. I can't do that. You can use ... as many times as necessary to reach the root directory. Okay. Temp directory. Using relative paths. Using symbolic links. There are symbolic links pointing. This is a slash. Using find with wildcards. This will help you search through the file system without needing to specify exact paths containing slash. This is only going to search in the current directory. Using built-in shell variables. Okay, so the tilde is the home directory. Using hexadecimal or octal encoding. Using PWD. Using built-in commands like cd without arguments. If you issue the cd command with no arguments, this will take you back to the user's home directory. Using file descriptors to access the root directory. Piping commands. Okay. This only does the current directory. This is no good. Okay, so let's try echo. This is a bad request because the localhost is not correct. Okay, so let's try. So we tried asking ChatGPT. Let's try looking online. Maybe we could take a look at hack tricks, OS command injection. Okay, command injection. Limitation bypasses. Okay, bypass Linux restrictions. Let's open this up. Parameters. So there are parameters that could be vulnerable to code injection. Time-based, DNS-based, filtering bypasses, Windows, Linux, bypass Linux restrictions. Let's take a look. Brute force detections. Okay. Bypass Linux restrictions. Reverse shell. I don't want to do reverse shells. Bypass paths and forbidden words. So question mark binary. Question mark binary substitution. So if certain strings are restricted, you could try using the question mark. Wildcard binary substitution. Wildcard and local directory arguments. Characters. Quotes. Oh, you know what? I could try using this to bypass the double period. So we could try something like ls-la, and then we could do dot, and then we could encase the dot in these square brackets. So the square brackets worked, I think. So all right, but this still doesn't let us. So this lets us use the double dot, but it doesn't let us use the slash. So that's that could be a problem. Okay, so quotes, the echo, characters, okay, quotes, backslashes. Oh, maybe we could do backslash slash. Backslash and then slash like this. So okay, that results in a bad connection, a bad request rather. Okay, so let's take a look. Execution through .0, or sorry, I think the transformations, uninitialized variables. Okay, we could do new lines. These 4 lines will equate to ping. Okay, fake commands, bypassing forbidden spaces. Bypassing forbidden spaces. Okay, so this is for space. Bypassing backslash and slash. Okay, so maybe we could do a trick like this to bypass the backslash. So let's try this and see if we can take a look at Etsy password. So if this lets us look at Etsy password, then we have then we're back in business. Okay. So let's paste this in. So this didn't work. It didn't work maybe because it doesn't like these curly braces. So if it doesn't like the curly braces, we could try using a backslashes to okay, so this did go through, but it didn't give us any output. which is unfortunate. Okay, so let's look further. So we could also do cat. Let's see if this particular method works. So let's copy this, highlight, copy, and try this payload. Paste it in. This looks like it's going to result in some weird stuff. Okay, so this also resulted in a bad request. So it doesn't look like bypass with hex encoding. Bypass with hex encoding. Okay, so we're echoing. What are we echoing? What is the hex encoding for this? Let me just grab this and do hex to ASCII. Hex to ASCII, please. All right. Etsy password. Okay. Well, let's see if this bypass works. Okay, so let's replace our payload with the one we got from HackTricks. Okay, so that didn't work the way I was expecting it to. Bypassing IDs, okay, getting characters from environment variables, built-ins. In case you cannot execute external functions, only have access to a limited set of built-ins to obtain RCE. There are plenty of handy tricks, okay? Polyglot command injection, bypass, potential regexes, bash fuscator, RCE with 5 characters. Let me see if I can Google search for something. So OS command injection through HTTP host header. HTTP host header attacks. Exploit vulnerable website that handled the value of the host header in an unsafe way. Okay, let's see if I can read up on this. Host header vulnerabilities, understanding host header injection attacks. Okay, so let's host header injection attacks. Okay, so password reset poisoning. What is opposed to the HTTP host header? Virtual hosting. Routing traffic. How to prevent these attacks. Understanding host header injection attacks and how to prevent them. Host header injection, okay. Let's get rid of this. Okay, so this example, the attacker has included a malicious host header value with a new line character. If the web server does not properly sanitize the host header value, it will interpret the X, okay, allowing the attacker to inject malicious content or steal sensitive information. Prevention techniques, conclusion, okay. let's go back to ChatGPT. Okay, so we are forming a OS, NOS command injection attack through the host header. So this qualifies as a host header injection attack. What are some common filter bypasses for host header injection attacks which want to use the slash character in the payload? Here's a collection of common host header injection filter bypasses, focusing specifically on overcoming the restrictions on the slash character. Use relative paths. Okay, so instead of using slash to denote directory levels, you can use relative paths like dot and dot dot. For example, to go up 2 levels, find, this is a common bypass with the slash character is blocked, allows you to navigate directories using relative paths. Hex encoding or octal, hexadecimal encoding or octal encoding. Okay, so does it interpret this? Let me try this and see if we can get the space in hello world. Wait. Okay, let's try it out. Okay, so here we're going to inject our, just like this. Okay, so it interprets this literally. So that doesn't, this interprets this literally, so it doesn't work. Okay. So wildcard characters, okay. There's a slash in here. Why is there a slash in here? You can also use star to refer to multiple directory levels, using backslashes to escape the slash character. In some cases, escaping the slash character by using a backslash may allow you to bypass filtering. If the filter is naive, it may not properly block slash if it's escaped. Base64 encoding. Okay, so I don't think this worked. CD and relative path navigation. Use PWD to determine the full path. Using symbolic links. URL encoding. URL encoding. Does URL encoding apply for this app? Okay, so let's see if URL encoding works on this app. URL encoding worked. URL encoding worked. So can we just do this? This, is it, wow, okay. So let me add this to the notes. It turns out that the slash character is filtered on this app. This might, this is probably due to the slash character being restricted in the slash character being restricted in the hosts in the HTTP host header. We were able to bypass the restriction by using URL encoding. For example, ls, and then what was it? Let's scroll up a little bit. %2f. %2f was able to get us the contents of the top level directory. Okay, so that means we need to look for the flag file. So what is this entry point.sh? Okay, so let's cat that file out. Entry point.sh. Okay, that didn't go through. This did not go through. It might be because we don't have permissions on this file. So let's run this. Okay, so entry point.sh is not allowed. Is not we cannot read it. So that's why we're able to read it. Okay, so let's try looking at the contents of some directories. So obviously we can't look at root. We could look at home. So let's look at the home directory. ETSCTF, okay. Let's take a look at, so %2f, and then it is ETSCTF. Okay, so it doesn't look like there's the flag file in here. So what we want to do is we want to find the flag file. So find, and we're going to look for name flag.txt. Okay, so it didn't get anything back. It might be because there's okay. So dash, the minus is not an illegal character. So it's probably because of some errors. So if there's some errors, we could, oh geez. Okay, so it's %2f dev and then %2f null. And let's see if this works. Okay, so this also didn't work. It might be because the greater than symbol is not allowed, in which case we would need to replace the greater than symbol. So in URL encoding, and let's do this character. URL encoding reference. Okay. So let's take a look at the greater than character over here. It's %3e. %3e. Okay, so this didn't quite this couldn't quite work. We could try looking manually in a bunch of different directories. Might be a bit tedious, but so it's %2f. Okay, so we've got this stuff over here. Where would we find the flag? So everything, it looks like everything's owned by root. I guess, well, I mean, that makes sense. Where could we go from here? So let's look in. Let's look in the var directory. Okay, so the var directory. So var and then www and then HTML %2f HTML. We've got index.php. So where would we, let me take a look at the challenge page one more time for any other potential clues. A brainless pingy or else pingy without brain. Command injection basic non-rootable. Okay, so could we look at could we try netstat? No, netstat might not exist. What other directories could we try looking in? MC25, are you not allowed to have a shell on it? I think we could have a shell on the host, but I don't see a big benefit to getting a shell on the host. I guess it would make, like navigating the file system a little more easy. But this challenge is specified as non-rootable, which means that getting root isn't the goal of the exercise. The goal of the exercise is to just get a flag. But I guess if we were to get a shell on the host, I would be able to run my find commands because I don't seem to be able to run find commands on this host. Let's maybe we should try to get a shell on the host. So let's ask which netcat to see if there is netcat. So netcat exists. Let's take a look at our ifconfig. We've got, so this is our address on the network. Maybe we could try getting a shell. Okay. Mustafa A, hello, there's a CTF challenge happening. Would you like to try it? Mustafa A, I took a look at the CTF website that you linked to me. This is an active CTF, and I can't solve active CTF challenges on stream because it goes against the spirit of competing in CTF challenges. I'm sorry, I can't help you. But let's see, MC25. If you're interested in trying out the challenge yourself, then it is this challenge right here, I've provided the link in the chat. Okay, so we could try getting a shell on the system. So we would do that by, oh gosh, what is the oh, and MC25, welcome to the stream. Nice to see you here. Nice to see you here as always. Let's give you a fun redeem. This one is all the things. Drink all the booze and hack all the things.
This one's dedicated to all the hackers. Yo.
Okay, so let me grab my my reverse shell commands. So this is the I don't remember the name of the user that suggested I look up this this bird, but this is a very pretty bird. Okay, so what were we doing? Reverse shell cheat sheet. I like looking at the one from Pentest Monkey. Here we go. So some versions of Bash can send you a reverse shell. Okay, let's try this one. We got the Python one, we've got the Netcat one, we've got the Netcat one without. So let's try the Netcat one. Hold on. Okay, let's try this Netcat one. Okay, and we need to specify the ports. We need to specify the IP address. There's the IP address. We need to replace these slashes with the URL encoding. So URL encoding is %2f, %2f, and %2f. Let's see if this works. Okay, so this looks promising, and it looks like we have a shell. Okay, and let's start looking for that flag. So we're doing find slash name flag.txt dev null. Okay, let's see if we get any results from this. So let's let that run for a little bit, and let's look back at the challenge page. Thank you very much for the suggestion to try to get a shell MC25. I really wasn't thinking about it because all these other targets were not rootable, and I really didn't think that that we needed to get on the system in order to look for the flag. But this might be the right way to do it. So back at the challenge page, a brainless pingy or else pingy without a brain. Okay. We haven't discovered any flags. It says that we haven't discovered this service. So I'm not sure what kind of service we should be looking for. You know what I should do is I should do a more thorough nmap scan on the target. So the target is this right here. And let's scan for all the ports instead of just the top 100. with 4 threads. Okay, so port 80, of course. That's what we're looking at right now. So I should have run this as a. I don't know if I had jobs over here, but it looks like I'm kind of stuck unless I want to break my shell. But I don't think there are any other ports open on the system. I could be wrong, of course. I thought this was going to be a very straightforward challenge. A brainless pingy or else pingy without brain. Does this have is this some sort of clue as to how to finish the challenge? You know what? I'm going to break my shell. Okay, so let's do that again. Okay, I've got my shell again. Let's try to stabilize the shell with Python. So which Python? Okay, we've got Python. So it's going to be Python command import pty, pty.spawn, bin bash. Oh no, I used the wrong quotes. I need to use single quotes here. Import pty, pty.spawn, bin bash. Okay, now I've got a slightly better shell. I can't do clear. So there's this interesting script file right here, entrypoint.sh, but I can't read it. So let's take a look at the home. Actually, let's take a look at the Etsy except no. The opt directory. Nothing in the opt directory. Okay. Let's take a look at the home directory. So we've got the ETSCTF directory over here. TSCTF. We've got our bash logout, bash rc profile, bash rc, bash profile. We've got our SSH. Interesting. We've got our authorized keys. Of course, it doesn't look like there's anything. It doesn't look like this file contains anything. There's nothing here. Okay, there is something. There's no sudo command. What other interesting directories could we start snooping around in? So not the temp in the temp directory? Nothing here. Okay. Where else could this... Okay, so let me try finding flag.txt in the background. So name flag.txt, and let's dev null, and let's run this in the background. Okay. So hopefully, hopefully it'll find something. But if not, then at least it's not getting in the way of us snooping around some more. So Docker and, oh, that's not a directory. It's also empty. So this is probably a Docker instance. Netstat? Netstat is not here. How do we look at open networking ports without Netstat? Let's do ps awk. Okay, so we've got our, it's running entry point, it looks like. We've got our Nginx, we've got our Python. Think ss.tuln, but I could be wrong. I don't okay, let's do that. ss.tuln. So we've got port 80 and this weird port over here. I wonder what this service could be. Maybe we could try doing netcat. Let's look and see if let's do our nmap scan one more time. Okay. Pingy without a brain. So what could this service be right here? Netcat 127.0.0.11 on 39801. That didn't do anything. Three 9801. Let's try 39801. I guess we could try curling it. Three 9801. Okay, that didn't do anything. Okay. What other directories could we start looking around in? Oh, you know what? Let's cat out etc password. So there's etsctf. Wait, is this is the flag? This is the flag. It was in the Etsy password directory. What the hell? I can't believe it. I feel so dumb. All right. I'm going to copy the flag and I'm going to root the machine. Okay. Submit the flag. Okay. 200 points. Yeah, we got the weather machine. Now we need to add that to our notes. The flag is in the Etsy password file. Smiley face. Okay, we finished. We finished. It only took us like an hour and a half to finish that challenge, and I feel really dumb. Okay. Well, anyways, let's it kicked us out. Okay, no problem. Let's see if we can do one more. We're gonna start one more challenge. I thought that these challenges would not be so tough, but echoCTF isn't playing around. And okay, let's move on to our next challenge. So target will shut down in. Okay, that's great. Let's go to our networks. Once again, we're doing this network right here called the HackGDL network, and there are a bunch of targets in here. If you want to take a look at the targets in here as well, you can go over to this page right here. MC25, thank you very much for your help in enumerating the machine. I always appreciate suggestions. And since we managed to root the machine, well, we didn't actually root the machine, but we complete the challenge. I'm going to play this redeem right here. I'm root.
What are you?
I'm system root.
Okay, so let's move on to the next challenge. The next challenge is this challenge right here called Webhound. Webhound. All right, let's check it out. Oh, it's got 3 flags. All right. So the Webhound challenge, if you want to check it out yourself, you can do it right here. Holy Webhound Batman, did you see that? Can you sniff out all the flags? Are you a super Webhound? All right, let's so it says Web Basics, basic, non-rootable, timed. Let's start up the machine. Power it up. I'm hoping there's no super complicated stuff involved in completing the challenge, but let's check it out. So we've got a web page, and we probably have to do some web enumeration on it. Let's copy this URL. No, this is not what we want. We want to copy this and then paste this in with HTTP. Okay, we here. Did you see that, Batman? Holy Webhound. All right. So this is a basic web challenge. So let's check if there's a robots.txt file in here. And there is. And here's a flag. So let's highlight this and then see if we can submit this as a flag. Okay, we discovered this, and we got credit for the flag. Let's move over to this directory right here and continue. What is this, an empty web page? Let's take a look at the HTTP source. And this is another. So this looks like the same flag. So we don't need to submit this. Okay. All right, so second of all, let's take a look at the HTTP source in the landing page. So we have here a style.css link. So let's open up that link. Whoops, nope. Let's just open the link. Okay, we've got our style.css. I don't think we don't see a flag in here, and we don't see any references to other files. So this is probably not what we're looking for. We also have this webhound.png. Looking at this doesn't necessarily give us anything. So the next thing we need to do is we need to do some web enumeration. Let's copy the URL for this. Okay. And then we're going to be doing a little bit of GoBuster. GoBuster! GoBuster in directory mode. And let's plug in our URL. Okay, so if there are any suspicious directories, we'll be able to find this. We'll be able to find it using so there's an admin page. So just for fun, okay, we don't need this anymore. Just for fun, let's run Nikto on this. So Nikto. So Nikto is a web app vulnerability scanner. It can find a lot of low-hanging fruit vulnerabilities on web servers. Let's see if it gets us anything good here. So this is Nginx, this version right here. I'm going to let this run for a little while. We found an admin page over here, so let's check out the admin page. You're a smart one, aren't you? Here's something for your troubles. Okay, so we got our second flag. So we only have one more flag we need to look for after this. So echoCTF, submit the second flag. So this is a much easier experience after doing that that pingy challenge for the last hour and a half. Okay, so we found the admin page. Let's take a look and see if Nikto found anything. So there's a robots.txt entry, of course. So this GoBuster scan is going to run for quite a while at this rate. I don't know if we should do some other enumeration while we're waiting. There's not this web app doesn't necessarily give us a lot to work with. Let's see if there's just a flag.txt flag. Nope, flag.txt doesn't exist here. So is this an HTML file or is this a PHP file? Let's find out. So index.php. This is not a PHP file, so I'm guessing it would be an HTML file. This is an HTML file. Okay, so I don't think we're going to get a reverse shell on this target. So, Holy Webhound Batman, did you see that? Can you sniff out of the flags? Are you a super webhound? Is this a clue into how we're supposed to exploit the target? Webhound, Holy Webhound Batman. Is there a Holy or Webhound or Batman directory? Holy, no. Webhound, no. How about Batman? No Batman directory. Disappointing. Okay. So let me try. So the robots.txt file over here. Let's try running a derb on the target instead. No, that's not what I wanted. Let's copy that, but make sure that we get rid of the Batman portion. So the derb word list is much shorter than the than the word list I supplied for the GoBuster scan. So this scan is going to probably finish a lot faster than the Durbuster one. So the Durbuster one is still going. It found admin, which is nice. And this one also found admin. Okay. So there's one more. So there's a robots.txt file. Okay. We found the admin flag over here. What are some other login? Let's try login.html. Batman.html. Whoops. That isn't gonna. I should use dots and not commas. Login.html. Nope. What about sitemap? Sitemap.xml. Nope. Admin directory. What is one other super? Oh, you know what? I should curl. I should curl this. Let's we're not doing derb, we're using curl and we're doing very verbose just to see if there's anything hidden in the response. Okay, so we did very verbose with curl and we got, did you see that? Batman? Holy Webhound. Okay. We've got an e tag. So there was nothing. Let's try sending a couple of different methods. So let's try sending a post method. Sample data. Data sample. And see if we get anything. Okay, so upload completely sent off 11 bytes. Not allowed. Okay, this is not allowed. Let's try a head request. So the head request was successful. That didn't get us anything super special there. Admin directory. What else could we try? We could try URL parameters, maybe? No, I don't think, index.html. Webhound.png, style.css. This doesn't give us any clues as to where else we can go in the app. Okay. So there was an admin directory. Let's open up a couple of new tabs and do some additional scans. So I want to complete my Nikto scan. And I also want to complete my derb scan. So we've got a lot of tabs and a lot of scans going on. Let's open up another tab because we can't have enough tabs. All right. So if anybody's wondering, we're testing against this target right here, which is called Webhound. And this is on the echoCTF network. Can you sniff out all the flags? Are you a super webhound? So we managed to find a robots.txt file, and we found an admin in an admin directory, but there's one more flag we need to discover. Question is, so somebody else was here about a day ago, and they managed to finish the entire thing in 11 minutes. So it has to be something super obvious that I'm missing. So there's a robots.txt. Okay. There is an admin directory. This scanning is very slow over here. If anybody has any suggestions as to, you know what, I could just ask ChatGPT what are some suggestions. Okay, we're doing a beginner level web app CTF challenge. DevTools. Yeah, we could try that. Let's see. So we're here, and we're going to go to this page right here. Whoops, we don't want that. We want to open up the DevTools. So more tools, web developer tools, and we want to take a look. Oh, it's cookies. No, wait. There's no cookie. Okay. Let me just check for cookies really quick. So there's no cookies here. There are no cookies for this host. Local storage, no cookies. Let's take a look at the network and see if anything funny happens when we load up the page. Okay, so there's, what is this? So we got the webhound.png. Could there be something in the webhound.png? Could there be a flag in there? You know what? We could try just downloading this. Copy the image link, and then in one of our spare tabs, we can get it down. Could if it's CTF. Yeah, that's true. So let's do strings. Oh no, EXIF data. EXIF tool. EXIF tool, webhound. Okay, no flag in here, but let's strings it with an S. And let's grep for ETS. Nope, no flag in here. Yeah. Okay, let's try to look for strings that are over a certain length. So for example, let's look for strings that are over 10 characters in length. Wait, why didn't that go through? Okay. So the network only recorded webhound over here. And this file is just a font, and this is a icon. So 5 requests. 1, 2, 3, 4. Wait. This isn't. Download failed. Download failed with this. What is this? Let's copy this. This file was not found. Okay. So we're here. We know that there was a admin directory, and if we navigate there, we only get this. Oh, you know what? We could try looking inside of the admin directory. So we could try. Mm-hmm. Admin directory. Let's try scanning inside the admin directory. So let's do GoBuster again. GoBuster again in dir mode. And let's look inside of the admin directory. That's not it. We want to look inside admin. Okay. So we've got this going. We've got this going. Robots.txt admin, admin index.php, admin.index.php. This is a PHP page. Index.php. Okay, so this is a PHP page. There's nothing super interesting about this aside from the flag that we already got. We're scanning inside the admin directory in this tab. In this tab, we're doing our Nicto scan. In this tab, we're still scanning the web root. And here we're doing our derb scan. Okay. So let's do some manual enumeration inside of the admin. So, okay, that doesn't work. So robots.txt. So admin, so robots.txt pointed us to this web page, but this web page is not anything super, I don't think it's anything super special. So it keeps on trying to load up this favicon. So, and the inside of, so there's just this. And I'm pretty sure I've already submitted this flag. Admin PHP, index.html, we found the admin. Robots.txt was found by derb. So this is an Nginx server. Are there any special files associated with Nginx servers? You know, I can just ask. Let's see. We've found a robots.txt file and a /admin folder. The server is running Nginx. Are there any other common places we should look for flags? Hidden files and directories, okay. Default are backup, old, uploads, test, hidden, private. Slash Nginx status. Okay, let's try that. Is that how you spell it? Slash Nginx dash status. Nope. Slash logs. Slash logs? Okay. Okay. Not relevant. Private, hidden, sensitive files. .ht access or .ht password. .ht access, .ht password. Config.php. Flag.txt or flag.php, secret.txt. Um, where are we? Okay. What were these suggestions? Config.php. So that could be in the admin directory. Um, Not in this case. Okay. Database.sql, .htaccess, or .htpassword. .htaccess, .htpassword. Nope. .git directory. .git slash head. Not here. Default pages, php info.php. Look for API endpoints. Nope. Subdomains. Subdomains? I guess we haven't done subdomain enumeration. So we could try doing some subdomain enumeration. Let's take a look. Okay, so we can try GoBuster in subdomain enumeration mode. And let's try it with no, that's not it. Let me grab the okay, I don't think we're going to find anything in as far as subdomains are concerned. But let's just keep this going. So GoBuster derb, also derb, also GoBuster derb, Go Buster. Go Buster. Go Buster. Okay. So one more time. Oh, you know what? We could also try doing curl with those other endpoints that we found. So just in case there was anything unexpected there. So let's do one more tab. I've got so many tabs. Okay, so it's curl very verbose. And let's try this with the admin endpoint. Moved permanently. Huh. How do we follow redirects? How do you follow redirects with curl? Let's ask. How do we follow redirects using curl? Follow redirections with headers. If you want to include request headers while following, if you want to see more details like this, to follow redirects using curl, you can use the dash capital L to follow these ones. Okay, so dash capital L. Okay. So let's see the one that goes to robots.txt. Okay. This is what it looks like, and let's try the one that goes to this one right here. Okay, so let me make sure that these are all different flags, or all the same flag. This should be the same flag. 28, 28. And this one over here is the admin flag. We didn't find any subdomains here. We finished our subdomain scan. Didn't find anything. Found the admin one here. Okay. So admin has an index.html and an index.php. That's interesting. Let's see if those are different. So in the admin directory, there's index.php, and there's also an index.html. Are these the same flag? So this one is B4, and this one's different. This one is different. Wait, let's try, okay, let's try submitting this. Yeah, okay, we've claimed it before. Okay, so let's try the PHP one. This looks like this is a different one from the other one. Oh my gosh. It took Derb to to find that for us. That's funny. That's really funny because most people consider Derb to be the inferior directory busting tool. But okay, okay, let's claim this flag. All right, flag, paste, claim. Done. Done, done, done. Okay. So let's do our write up for this machine. This one was called Webhound. Webhound? Yeah. Webhound. And I'm going to create my notes file so that we can take our notes. Okay, and let's make this nice and big. Zoom in, and then zoom in, and then zoom in. And of course, let's do our I'm root redeem. Thank you very much, MC25, for the encouragement.
What are you? I'm system root.
Okay, so found first flag in robots.txt. Found second flag in the admin landing page. Found third flag in alternate index.php page under the admin folder. Huh. Okay. So I'm going to note that I found that using derb. Anyways, okay. All right, so it's past my bedtime. But thank you very much for coming by and watching me struggle with easy level challenges. Thank you very much to MC25, and we're gonna be back on Monday. On Monday we'll be back. We're gonna be doing some. We're probably going to be doing more of the same. We're going to be playing some Baba Is You, and we're going to be doing some hacking afterwards. But everybody have a great weekend, and we will see you next time. Thank you very much for coming. And let's go out with some Hack the Planet, because that is what we do.
Hack the planet! Hack the planet! Shut up and get it.
Thanks for watching, everybody, and have yourself a great weekend.